Myself, I currently work at Buff. Buff is a Protobuf sort of company, so kind of on topic. Previously, I worked at Lyft. I was one of the first Android engineers there. So I got to do a bunch of things related to driver, rider. For those of you who don't know what Lyft does, you probably heard of our competitor, Uber. So Lyft is also a rideshare company. So at Lyft, I moved all of our mobile engineers to Protobuf, as well as working on other ancillary projects like onto mobile. But outside of software, I like doing pottery and bouldering, like most software engineers. And that's my dog right there. So I'm going to get started with how mobile development worked at a previous team of mine. So for our project, the first thing that we do is figure out the API between the iOS engineer, the server engineer, and myself. We do that via like Slack or Google Docs, or maybe we even text each other. Sometimes that works. And from that, the team kind of gathers together, gets comments through, tries to figure out what will work, what will not work. And from there, we all kind of break apart in parallel, and we implement and embed whatever we decided for the API into our specific applications. Then we get to do the application logic, and finally, we release the feature, enable the feature, or do end-to-end verification at that stage. But the thing that I like to focus on usually is the application logic, providing a better user experience for our customers. So I'm going to get started with an example where this might be something that you've kind of faced before. So this is a collaboration anecdote of an API that we had at a rideshare application. So we have a rider and driver app, both polling to understand what the state of the ride is. And when one person cancels, either the rider or the driver, we need to be able to understand who did it as a rider. I need to understand if the rider, I canceled, or if the driver canceled. Similar so for the driver side. So an API that does this is probably pretty simple. We're going to get an API, we're going to have a cancellation actor, and we'll just tell the app who did it. So super simple. Something like that, right? Cancellation, we have a string for the passenger or driver. So with that, we're going to encode the API. I'm an Android engineer. We use Kotlin, so we're going to do that straight up. Data class, let's go. Then the iOS engineer comes along, does their own thing. They do their own thing. And you can kind of tell there's a bit of a mistake here, right? The cancellation has two L's in one side and one L in the other. What would that mean for the server? Something weird. So the server either has to do one of two things: an if-else to only send the two L's to one platform, or they just indiscriminately send both of the keys and call it a day, right? So that's not really great. We can actually solve this problem with an API schema. So with an API schema, we can then have a language that describes our API. If that language is able to be compiled and used for generation, we can even generate code for all the platforms, right? That would be amazing. And with that API schema, our development process would then be develop the API, and then we get to focus on the stuff that we like. So that's awesome. So Protobuf does this. And I'm going to walk through how the previous API would potentially look in Protobuf. You can ignore the syntax part for now, but the package is very similar to what we all are familiar with. And the bottom there is the ride update response. You can tell that there's this object actor, but the cancellation underscore actor key is going to stay the same. And with the object actor, we can actually define what an enum is and actually use an enumerated value and not, free-form strings, which means that our calling code can actually look something like this, which is a lot nicer and more exhaustive. And with that, with Protobuf, our API design becomes described in a Protobuf file. When we write the Protobuf, we can open up a PR and have that for review. Our teammates can come in, comment, say like, well, I kind of like the two L's more, or the one L, And you can have the conversation there. And in that like PR, you get to save that context. In the future date, when someone comes in and are wondering why isn't it 2 Ls or 1 L, they can kind of see the discussion of me and the iOS engineer going at it for a little bit, right? And with that, like we can generate all of the APIs that we would use and not need to handwrite it anymore. So with the API schema, we have a single source of truth for all our APIs. We get the documentation that we wanted, all the comments still there. The change history, so if an API mutates over time, it's in GitHub, and you can kind of see how it changed. The cross-team collaboration becomes even easier because it's with the tools that we've all been accustomed to, the GitHub PR or whatever PR you all use. And the big thing is backwards compatibility checks. So there are problems with older clients not understanding a specific key. With Protobuf, you can there is a feature for backwards incompatibility. So previous APIs would have to be compatible with future APIs, and it would break a build. A CI would break to sort of notify you of that. For the generated code, it can be very idiomatic. It doesn't have to be very like ugly. It can be what you kind of like are accustomed to. And at the end, we get to focus on the fun stuff. So it's going to be something like this. But outside of the data structure, like the data transfer object, we can actually describe more with a Protobuf. So beyond requests and responses, we have RPCs. And in the previous example of a write update request and a write update response can be kind of modeled in Protobuf in this way. With a service ride and an RPC update, it accepts like a request and it returns a response. So in this case, like this service, this endpoint is actually described in this sort of fashion. And with that, the generated code can be something like this for Kotlin. And this is just an interface, but obviously the implementation is included. But like you can kind of use this and kind of understand the relation between the two. So that was actually Connect generated code, which is something that Buff has created to be interoperable with gRPC. It's open source, and it's the easiest way to use Protobuf on Android. For more advanced users, Buff, my company, has a schema registry, which allows organizations to sort of centralize all of their Protobufs in one area. Happy to talk more about that after. But that's all I have. We have a Slack channel, so if you are interested, come join it. Questions? No? But if you have any other questions related to Protobuf, me and my colleague Michael is going to be around, so don't be a stranger and come up to us and chat.